Good morning. Today I'm going to have you watch this little video and take some notes on something that you've done a little bit of it before. I think we've even done a little bit of it in here, but I'm going to introduce a new type of function that we're going to be working with in the near future. So we're just going to jump in and get started. All right, so it would be good if you were taking notes. So we're going to call these notes 3.1. And we're going to be evaluating functions. Oh, can't spell. Evaluating functions. All right. And then we're going to do an intro to piecewise functions. Okay? All right. So the first thing we're going to do is talk about function notation. And so I'll write that down. Function notation. All right. So we're talking about equations, all right, of functions, but not like the quadratic equation where it's equal to 0. I'm talking about like equations where you have like y equals something, all right, but you're not going to see y very often in this class. You're going to see it more in what's called function notation. So y is the same thing as saying f of x equals, okay? But it doesn't have to be an f. It could be a g. It could be an H, it could be an M, it could be anything I wanted it to be, okay? But when it says f of x, all right, that's just function notation. It means the same thing as y equals. All right, so now I want to look at evaluating some functions. And again, this is something you should have done a little bit of it in Algebra 1. All right, so we're going to be evaluating functions. All right, so I have to give you a function. All right, so I'm going to say given f of x, that's the name of my function, equals negative 3x plus 1. We'll start with something pretty easy. And I want you to find f of 10. Okay, now if you look at f of 10, hopefully you realize that 10 is in the same spot, all right, as the x in the equation, okay? And so that's literally what it means. It means plug 10 in place of x in the function and simplify, okay? So we're just going to do the math. We get negative 30 plus 1, and we get negative 29. So f of 10 is now equal to negative 29. All right, and so that's what I mean when I say evaluate a function. I'm going to give you a function, f of x, g of x, h of x, whatever, and I'm going to tell you to find something, and you're going to plug that number in for x. Okay, so let's do another one. All right, how about given g of x, I want to change up my notation a little bit, equals x squared plus 7, all right? How about we find g of 3, all right? And maybe you want to take a second and try that on your own. That would be awesome, okay? Because again, I'm pretty sure you've done something like this before. All right, so all that means, hopefully you paused it and you took a second to try it again. We're going to plug 3 in for x. You don't have to use parentheses here, but it's just a good habit to get into when you square something. All right, so hold on. Okay, sorry about that. I had to pause. I know that didn't take up a lot of time in the video, but I did have to stop for a second. So let's finish the math up here. 9 plus 7 is 16. So, and you don't have to rewrite it at the end like this. The final answer is 16, but I just want to point out that g of 3 is 16. Okay, you don't say x equals 16 or anything crazy like that. Okay. All right, let's do another. How about given h of x, again, I just want you to know it doesn't have to always be f, equals 12 divided by x. Let's find h of -2. Okay? Well, that's not going to be too bad. That just means plug in -2 for x, and 12 divided by -2 is -6. And that one was pretty quick and easy. Okay? And I've got one more before we look at our intro to piecewise functions. So let's look at our fourth problem here. All right, let's go back to calling it f of x. And let's say that you are given f of x equals x squared minus 5x plus 8. All right? And I want you to find f of -1. All right, and the reason I put this problem here is because you do have to be careful when you plug in negatives and you have to square it. All right, then we've got a -5 times a -1 plus 8. All right, so I'm going to do my math. Maybe you can pause it and do your own math. And then we put it back together. And again, it's just a good habit to write the whole f of -1 equals 14. But you could just say 14. Okay? All right. Now I want to talk about piecewise functions. So now we're going to do our little intro to piecewise functions. All right. So first of all, I need to tell you what a piecewise function is. All right. Well, a piecewise function, all right, so it's like a definition here. A piecewise function is a function that is made up of two or more functions, each with its own domain. And we'll talk about that in a second. Okay, so right now you just need to know how to evaluate piece functions. All right, piecewise functions. All right, so that's what we're going to do. We're going to evaluate each piecewise function. All right, so of course I have to give you a piecewise function. So we can call this number 5. We'll pick up where we left off. All right, and now you're going to see what a piecewise function looks like. All right, it is literally a function like f of x or g of x or h of x, okay, that is defined in pieces. All right, so we've got this piece x squared minus 1 if x is less than -2. So that's what it means by each has its own domain. So like if I were to graph it, I would only see the graph of x squared minus 1 for all the x's less than -2. And then the other piece is 5x plus 3 anytime x is greater than or equal to -2. All right, so I'm giving you that. All right, that is our piecewise. It is a function defined in pieces. And we're going to find a couple of things. I want you to find f of -5, f of -2, and f of 7. Okay, so lots of things here because you can, you could have found multiple things with each of the questions before. I just chose not to ask them that way. Okay, so let's do this one at a time. F of -5. So when you have a piecewise function, the whole idea here is that you have to look at the domain, okay, and see where your number, in this case -5, fits into that domain, okay? So I want to know, is -5 less than -2, or is it greater than or equal to -2? Well, hopefully on a number line you know that -5 is to the left of -2, so it is less than. So that means we are going to use the top piece, okay? But when I say use it, I literally mean plug -5 in for x in the top piece. Okay? Then I'm going to simplify and get my answer, and that is f of -5. Okay? All right, so if I ask you for f of -2, all right, that means up here I'm looking for the piece where I'm allowed to plug in -2. Okay? Well, -2 is a number in both, but the second one's the only one that has the equals -2 on it. And so that means for this one, we're going to use the bottom piece. Okay? All right, so if I use the bottom piece and plug in x, plug in -2 for x, then I'm going to get 5 times -2 plus 3 is -7. All right, so that is what f of -2 is. Okay? And then the last one I asked you for f of 7, so you have to look at your pieces and figure out where 7 would fall. All right, well, again, I'm looking to see if 7 is less than -2 or greater than or equal to -2. And it is, in fact, greater than -2, so we're going to use the bottom piece again. All right, so we're going to use the bottom piece. And that means we're going to do 5 times 7 plus 3. And we're just going to do our little math. We're just following any order of operations we need. And we get 38. Okay? And that's how you evaluate piecewise functions. All right, so I'm going to write down a second one. And then I would like you to pause the video and try them on your own. Then we will run through it. And then I'll give you one more, and I want you to pause the video, and then we'll run through it. Okay? So we're almost there. All right, 2 more problems. All right, so number 6. All right, given g of x equals, this time I'm going to give you 3 pieces. 1/2 x plus 3, if x is less than or equal to -4. -x minus 1, if x is between -4 and 1. That's actually how you read that. But you can say if -4 is less than x is less than 1. All right, and then I'm going to throw in a cubic, 2x cubed plus 9, if x is greater than or equal to 1. And I want you, I want you to find, okay, g of 2, g of -1, and g of -6, okay? And this is where I want you to pause the video and try these on your own. All right, I'm going to pause the video and fill in the work, and then we can come back together. Okay, so hopefully you did pause it. So let's take a look at the answers. All right, so if I find g of 2, all right, I'm looking first at my inequalities here to figure out where 2 fits in there. And 2 is bigger than 1, so that's why I use the bottom piece. All right, so then I plug 2 into 2x cubed plus 9, and I got 25. All right, then we move to the middle, g of -1. So I have to figure out where does -1, again, fit into those piecewise functions, okay? So -2 fit in here, okay? Or excuse me, +2, sorry. +2 fit here. All right, -1 is between -4 and 1. So -1 fits in the middle piece. So then I plug -1 in for x. Be careful because there was that extra negative in front of it. So we get +1 minus 1 is 0. And then for the last one, g of -6. All right, well, again, I'm looking at my inequalities. -6 is, in fact, less than -4. So I'm going to use the top piece. And then I plug in -6, and I also get 0. Okay? Hopefully you did pretty good on that. And I've got one more for us. All right, number 7. Let's call this one h of x, just for the practice on different definitions. And I'm only going to do 2 this time, but I'm going to have an absolute value in one of them. And I'm just going to say you're going to use that absolute value if x equals 2, and then 2x minus x squared if x does not equal 2. Okay? So that means, right, the top one means I can only use that line if x is exactly equal to 2. The second piece means I can use that line any other time. As long as x is not 2, I can use the second line. So if I want you to find, all right, let's say h of 2, let's do h of 3, and then let's do h of, I don't know, negative 1, okay? All right, so you can pause it here and try it, or you can work through it with me. All right, so h of 2. Well, the top line is the only line that I can plug 2 into. It's the only line that has an equals 2, and so I'm literally going to plug 2, into the top piece of the piecewise. All right, then remember absolute value is a grouping symbol, so you do inside first, and then you actually take the absolute value of it, and we get 6. All right, but if I were to check any other number, so h of 3, h of negative 1, I can no longer use the top line because those numbers do not equal 2. So both of them, I'm going to use that bottom line. All right, so be careful with, again, plugging in negatives and squaring and all that stuff, although this one's on negative. 2 times 3 is 6. The minus stays, then you square, then you subtract. Okay, so you got to remember your order of operations here. And then the last one, again, that's not equal to 2, so I'm going to use the bottom line. This one is negative, so definitely want to use those parentheses for the square. All right, because the order of operations says you square first, and then you would multiply the negative in front of that. So that actually becomes a subtraction problem, and our answer is negative 3. All right, so I hope that wasn't too bad for you. I have set up a very small, short 6-question assignment in Alex for you to practice this. Some of them are like the first ones, and then the last few have the piecewise functions. All right, thanks for your attention.